Is it possible to minimize the time and cost associated with improved security in embedded designs to prevent intellectual property theft or malicious reprogramming? Join me, Todd Baker, in this episode of The Current, and today we'll be discussing embedded system security and the critical role that it plays in various industries. So in the last few months, we've seen some major security issues with the Eastern Pipeline in the United States, where it's had a huge impact on the oil industry, on the economy of the Eastern United States, and really the global markets as a whole. And again, security becomes something that we as a society and we as engineers have to consider. Now, obviously, that was more of a software breach in security. And as embedded engineers, we're not quite looking at that, but we have to consider in the systems that we're designing, how can security potentially impact our designs? How can security impact possibly the network that our embedded system might be connected to? And certainly over the course of the last few years, we've seen embedded systems be a weak point, allowing hackers to get access to a larger network behind it. And also in our embedded systems, if a hacker were to get access to the embedded system, is there potential for danger or damage through having access to the controls of a generator, having access to the controls of a motor that could possibly be an issue? Now, with all of that in mind, we as embedded engineers are still constantly being asked to reduce system cost, reduce system size, reduce system power consumption, reduce system complexity, all while, making sure that we've got every feature that we possibly need. So it's very important, I think, when it comes to security, how do we as embedded engineers make that decision on the return of investment on adding security to our system? How do we know that that's going to be worthwhile in our system? And in addition to that, how do we become a trusted advisor to our companies and become a trusted advisor to our end users to convince them it's worth spending the extra amount of time in the design, that it's worth spending the extra amount of money to possibly add security to our system? Today, I'm very, very privileged to talk to Kimberley Dinsmore, who's the principal engineer in the Industrial IoT Business Unit at Renesas Electronics and is an expert in embedded security design. Kimberley, thank you so much for joining me today. I really appreciate your time.
No problem, Todd. Thank you for having me. Appreciate it.
Absolutely. And this is a conversation, as I was saying before we started the call, I've been really excited to do this interview and have this conversation for you because this is an area of embedded design that I think I've been trying to learn more about over the course of the last few years. And I think many embedded engineers are kind of in the same position. As I talked about, anytime we add any feature, any new feature, expanded feature to our embedded design and our embedded system, in this case, security, there's going to be a cost associated with that, whether that's the design time, whether that's having to add other parts to that design. So as embedded engineers, how should we measure the value of one spending that time and money? And also, how do we communicate that to our businesses that that's a worthwhile investment in the design?
That's honestly a question I get a lot especially from IDHs, because it seems that engineers in general appreciate the value of security. They understand the theory. They understand that these attacks are real, they can happen, and they can even target even embedded systems. And so they literally asked me point blank, how do we convince our customers to ask us to create products that use this? Unfortunately, the people asking for the products, creating the products, the OEMs, they have a different mindset than engineers. And so the first thing you have to do is you have to understand their pain points and where they're coming from.
Right.
And they're making products to create money. So, okay, to do that, they have to be able to sell the products. Are there legal regulations that require a certain level of security? This is a good one.
Yeah.
This one's coming up now. A lot of countries, EU, Europe, UK and such, there are very specific guidelines. California, the new bill there, it's not so new anymore, require a certain functionality in order to simply be able to sell the product in that area. So that's a good one to start with. If we want to do this, a trivial one is no default passwords. It sounds easy, but there's actually a little bit of infrastructure required to do that. So that's the first one. Look at the legal regulations. Another one is look at the competition. If you can say, look at this competitor ABC, they've already got this security solution. If we don't have it, no one is going to buy ours because we will be perceived as being less secure, less with the times, less knowledgeable, and
Yeah.
we won't be able to sell it. Those are typically two of the good pain points. Some of the other ones, unfortunately the major hacks and everything, those tend to get discounted. But if you can find their production pain points, things like cloning, losses to cloning, losses to IP protection, losses to overproduction, those tend to get more interest because those affect the OEM producers, bottom line. In other words, follow the money and see where their pain points are for that.
No, absolutely, and I think that's what we've seen in many of the different companies that we've worked with, is that a lot of times when you have that initial discussion on security, they're interested. Engineers want to talk about it, and all the way up to the CFO, they want to talk about it. But it tends to be on that first design. Well, I don't know if it's worth the investment, and then it's not till after, unfortunately, something bad happens, and then they're very, very interested in the next generation of design. Say, okay, Todd, we want to talk about security this time. We want some help, but at that point, there's already a sunk cost. There's already been some cost, maybe in some cases all the way to their brand, that they now have to do some damage control over. And it's a tough decision for a lot of companies out there. And I think it's one of those situations, and I think you've mentioned it to me before. It's where an ounce of prevention is worth a pound of cure.
Hmm.
And I think that's what security really ends up being. I think one of the things, as I have conversations with engineers, it's always a challenge is Black Hat hackers are a little bit of this kind of mythical beast, right? We don't really know what they're capable of. It's almost
Uh,
magical. And so even if we do put the investment in and take the time to try and stop those black hat hackers or somebody that would actually try and damage or get into our system, we don't really know what they're capable of. We don't know if we really have secured our system, if we actually put the effort into it. So from that standpoint, what are some of the things that a bad actor, a black hat actor, is going to be looking for in an embedded system to exploit?
well, it's really interesting because you say black hat or white hat, and
Yeah.
there really isn't a lot of difference in their techniques. They
Okay.
they're all looking for the same things. It's just the the reason behind what they're doing. I mean, white hat, they just love to get in there and break it and see what they can do. Is look at this, it has this vulnerability, like the Apple AirTags. Look what we can do.
Right.
Um, it's motivation. Black hat motivation is money. And so that's when it does scare you. But you can actually learn a lot from the white hats because they'll publish it. It's like, say, this is how we did it. The AirTags hack, you can go online and you can see a complete list of what they did to get it. Um, so if you go back to the black hat, their motivation is money, right? So
Yeah.
they want to work on something that will allow them to make money. The whole pipeline thing, right? They didn't care about bringing down infrastructure. They just wanted the money. So it's a
Right.
reoccurring theme here, isn't it?
Always
um,
is.
yeah, it really is. It's sad, but if you understand it, you can work with it.
Right.
Um, um, Still, the general principles apply. Big thing is IP. I mean, a lot of embedded systems have some really valuable IP, and a lot of times the engineers don't realize how valuable their efforts actually are. I've had engineers say that, "Oh, I don't care about my firmware. It's fine. There's nothing important in it." And it's like, no. Um, for example, we've got welding machines that have that where our customer has put in really nice proprietary IP for reducing sputtering, which is very important if you're a welder. If you're not a welder, you wouldn't think about it, but that sort of thing. And if a black hat can get that IP out and get those algorithms out, he can then turn around and sell them to a competitor. And so IP protection especially is really important in
Yeah.
the embedded world. You don't undervalue, engineers should not undervalue their own work and their own IP. Um, so just the
Great point.
very fundamental locking the MCU down such that you can't read it out. You can't read out the firmware is a huge step. Any other sensitive data, I'm sure we'll be talking about this later. Anything that has to do with keys, anything you can do to secure your keys. Those things are what primary hackers will do. They'll try to dump the IP and they'll try to get keys out. At a certain point, it turns out that the MCU is often not the weakest link in the chain. It'll be the people. There'll be other ways to get that information. So if you do due diligence on securing your IP, securing the firmware, and securing your keys, you'll go a long way.
Yeah, that makes a ton of sense, and I think I think the industry has been looking at new ways of integrating that kind of thing into systems, but it has been a lot of focus, to your point, on the MCU, and certainly big news from Renesas in the course of the last year or so with the release of the RA family, and you guys have started incorporating the M33, M23 cores and bringing in the ARM Trustzone into those cores in the microcontrollers. So talk to me a little bit about that. That the Trustzone is something that we hear a lot about. It's being discussed a lot, across the entirety of the industry. What does Trustzone bring to this to the engineer, to the system? How does it help to secure the system as a whole? And what should an embedded engineer be considering when they're looking at Trustzone and they've never done secure design before?
Okay, Trustzone is a really nice isolation solution. So you would use isolation as a part of your overall security solution. So it's not something like, oh, I've got Trustzone, my solution is automatically secure. Absolutely
Right.
not. It's a component. Security is layers, and isolation is a very important layer. For a little background, it came from the Cortex-A world, where you can easily see where it makes sense, because on the Cortex-A you have multiple applications from multiple people, some of whom you may or may not trust, and you want to keep just that extra layer of protection of your trusted, your very secure assets away from your potentially untrusted parties. Cortex-M world is a little bit, we're still finding our feet, honestly, to be honest, with with Trustzone, because a lot of Cortex-M applications are written by a single team or even a single developer, and so the idea of separating something from yourself still seems a bit weird to people. But it still absolutely has value, because of when you start having connected devices, that now have firmware upgrade capability, you introduce the possibility that someone else could actually infiltrate your system. And so even though it looks like you're protecting it from yourself, you may not be. Um, Trustzone just adds an extra layer, because it greatly reduces the attack surface. Without going into too much detail,
Yeah.
it's one of the it's an excellent solution for significantly reducing the attack surface on your secure area.
Makes sense. Makes sense. And then, so the other aspect, outside of just the microcontroller itself and actually being able to physically get to that system, is certainly everything these days is being connected more and more to the cloud. I think one of the more, a few years ago, one of the more publicized breaches was a big box chain, who I think credit card information was stolen based on a hacker getting through the thermostat within one of their stores. And so we've seen that kind of thing happen, where probably the engineer who was designing that thermostat never considered that someone would have access to credit card information, by using by using their thermostat. But that certainly happened. So, for any of these kinds of systems where, we're connecting to the cloud, or we're connecting to a Wi-Fi network, maybe just a local Wi-Fi network, what are some of the things that we've got to consider in that, where, to ensure that our system can't be compromised or be utilized to get access to a bigger network behind it?
Well, whenever you're thinking about cloud connectivity, or connectivity in general, the first thing you really honestly need to remember is that you need to make sure that your system is designed at the beginning to be updatable,
Right.
because threats always get worse. The attackers always get better. They're always really good at stringing together little bits like the thermostat, various little minute little cracks that all of a sudden you put them all together and you've got a major problem. So
Yeah.
it's always important to make sure that when you're designing your system, that it's updatable from the beginning. Of course, add on to that, you have to watch for fail safes. Make sure your design includes things like, what happens if there was a problem in the update you didn't see, where now it can't get a new update. So rollback is never a good idea, yet you do need to have some sort of fallback in case everything goes wrong that wasn't supposed to happen. So that sort of thing. As far as cloud connectivity in general, the most important part is the authentication. It's probably one of the most important parts in a security solution. Is, do you have permission to do what you want to do? And that's very important with cloud. There's a couple different ways to do it. There's typically two key types of infrastructures. One is a lightweight infrastructure where you share a pre-shared key.
Mhm.
Um, it's good for small devices. It tends to be more difficult to manage because you would want each device to have its own key, and yet the infrastructure now needs to know the individual key for every single device. Advantage is that it's very lightweight to create something like that. Um, what you really would prefer is to have some what we call our PKI, our public key infrastructure,
Right.
where the each device has a cryptographic identity, but the cryptographic identity is split in two pieces, and one that can be shared publicly and one that's kept privately. Um, that is typically the way you'd want to go for any sort of cloud connectivity where you have public key infrastructure and that sort of identity. It's the infrastructure is interesting.
Yeah.
It's not trivial, it's not simple, but it's well worth doing. The good thing is that there's a lot of partner solutions out there, or third-party solutions that are out there.
Mhm.
The cloud vendors themselves are a little bit slow, I've seen, on implementing really good device management systems for cloud onboarding and such at scale. However, there are several third parties that I've been working with personally, and I know there's going to be more out there, who have some really nice solutions for true device management, certificate
Okay.
revocation, that sort of thing. So I would definitely suggest, if you're going to design something, a big cloud infrastructure with a big IoT deployed system that uses a public cloud, to definitely look into some of the third-party device management systems, because they are really, really nice and will make your onboarding and device management a lot nicer.
Oh, very nice. Very nice. That's definitely something to consider. And you mentioned a really important point, I think, early on in that, which is, the ability to constantly, part of security is ensuring that you can realize where you've got mistakes and in the field upgrade your system's firmware to, block those mistakes, fix those mistakes, ensure that they can't be, continue to be a crack, as you mentioned, in the system over time. So, but in doing that and having the ability to upgrade your system in the field, upgrade firmware in the field, there's a little bit of an element of you're adding another potential security breach, area where, if you can upgrade the firmware in the field, and if a hacker were to find a way to upgrade the firmware in the field, or maybe read the firmware as it's being upgraded and again steal your intellectual property, that could be an enormous issue against you as well. How can designers ensure that malicious code is not going to be something that a hacker could take advantage of and would be able to reprogram one of your products?
Right. Well, the nice thing is there's a lot of the potential threats actually have very, very similar solutions. So if you go through the pain of implementing a public key infrastructure for
Right.
identity, you can leverage that for your firmware updates. Um, the basic concept would be PKI provides authenticity, so that way you would know that the new firmware is indeed from the source that you expect it to be from. The new firmware would be signed. The device would have the public key of the person creating the new firmware. The person creating the new firmware would keep their private key private, and as long as that key doesn't get compromised, you're good. A lot of people will have multiple sets of keys in case keys get compromised, so they'll have key rotation. Um, Another really, really great additional layer for security. Um, it um, it can also be done with pre-shared keys, with like symmetric keys,
Sure.
but you do have the additional issue of, okay, you've got to manage. Do you then program 100,000 of these devices all with the same key? It makes it more likely that the key will be exposed. So you pay for the simplicity with a larger attack surface. So again, PKI, it does give you provides a lot of answers for a lot of the security questions that you've got. In addition to that, we talk about authenticity, but the new firmware in general, when you download it, it's nice if it's not delivered over a secure channel, you really want to consider encrypting it, because you don't want somebody grabbing your firmware in
Right.
transit and whatever. If it's over a TLS connection, it will already be encrypted, so
Sure.
you could potentially not worry about that. But if it's over a non-secure channel, you can do that. And PKI has multiple solutions that allow you to deliver the firmware encrypted as well.
Okay, all right, that's great. Uh, and then, lastly, you mentioned earlier on that a lot of engineers don't consider how valuable the intellectual property they've created in their firmware really is and can be to black hat hackers who, again, to your point, are typically looking for money. So from that standpoint, intellectual property protection is absolutely critical for our firmware and making sure that it can't be copied. Sometimes that's as like we said, over during an OTA firmware update, or it could just be a matter of as we send our design over to be manufactured in another location, ensuring that that manufacturer only builds the specific number of units that we want built, and that nothing's going out the back door. That they're not able to take our firmware and sell that to maybe another competitor, or that gets out into the public market and used against our business. So, what are some of the things that engineers can do to make sure that they are protecting their intellectual property, and that none of those bad actors, whether it's a hacker, as we've been talking about, or maybe a bad acting CM who's producing a lower cost product that's a complete clone of what we've done?
I think you touched on it with there, where a lot of this is the manufacturing for production issues with contract manufacturers. That's usually where the problem is going to be. But the engineer is the one who has to come up with the solution to
Right.
affect that. And a lot of times engineers aren't even familiar with the production flow process.
Yeah.
So it's important that the engineers realize, okay, where is this product going and who's going to be handling it, so they can identify where the threats are, where the vulnerabilities are. I've got customers who have complete control over their manufacturing. It's done on site, no problem, and so they don't have to worry about this issue. Then again, we've got from the absolute opposite end of the spectrum, the contract manufacturers all around the world that may not be so trusted. Um, there's a few different solutions that you can look at depending on the flow that the product's manufacturing needs to take. The simplest, easiest way is to utilize something like your secure provisioning services,
Sure.
secure programming and provisioning
Yeah.
services. Honestly, that's a great solution.
Yeah.
Even if the firmware is firmware updatable, you can provide the provisioning aspect, the initial secure bootloader, and the first version of firmware, all to yourselves over over a secure in a secure manner. I believe your production programming partners are ISO 2701
Absolutely.
certified,
Yep.
which is absolutely brilliant. So customers can have complete faith that they can provide you securely with all this very sensitive material, and they'll get X number of devices returned to them. So they order 10,000, they will get 10,000, and then only 10,000, they can provide those 10,000 to the contract manufacturer, and the contract manufacturer can only build 10,000.
Great.
So that cuts down your IP, your overproduction right there. If you make sure that the devices are suitable for being able to be locked, such that you can re-enable the debug interface, re-enable the programming interface, then you don't have to worry about the IP theft, because the ISO certifications guarantee that to our customers, that the material is handled securely during the provisioning and programming process, and the MCUs are delivered in a locked state. So you don't have to worry about those. Some people don't have that option though. Sometimes it's a bit of a mix of a production flow,
Right.
and so sometimes what can happen is the devices need to be delivered with initial provisioning, initial identity, and initial secure bootloader, but for one reason or another, not the entire program, and that's okay. That can be done. What happens then is a lot of times that initial bootloader and initial test program will then be used at the contract manufacturer to connect to the OEM server
Hmm.
to download the first version of official firmware along with test configurations and test programs and such. And then the OEM server can then keep track of how many times that firmware has been downloaded and the identity of the device that it was used on. So that's a bit more complicated, but there are a lot of different solutions that we can look at, and we all can be very flexible to support the end product manufacturer to support their production requirements.
Perfect. And this is never a pleasant, I think, subject for any engineer to consider. I mean, it's never easy to take a look at what could be the horrible things that could possibly happen with our design. Where could things go wrong? But I think it's such an incredibly important part of our discipline. I think we've done this for years when it comes to surge protection and all these other different hardware type things that we've done. And I think it's going to be an incredibly important part of being an embedded engineer going forward, that we all get very familiar with securing our firmware and securing our overall designs to avoid any potential issues here. So, Kimberley, thank you so much for joining me today. I really appreciate your expertise and everything you bring to the table. Thank you.
My pleasure. Thank you.
So if you have any other questions on security, if you're looking to secure your systems, you want to talk to experts like Kimberley or the future electronics engineers who are also spending a lot of time learning about these products, we'd absolutely love to help you in your designs. Please reach out to us at Shaping the Future at futureelectronics.com. Again, Shaping the Future at futureelectronics.com. We'd love to help in your designs and help you look at the different options that are available to you and talk to the experts that can ensure that you're headed in the right direction. Thank you very much, and look forward to talking to you next time.